Hello everyone, myself Manas, and today I would like to showcase you all my new ML engineering project which I have created during this month. So it is an end-to-end fraud detection system which I have built using IEEE-CIS Fraud Detection dataset which is available on Kaggle. So the main aim is to learn by building. So this is the project which I am talking about, and let's jump into the main motive of this project, the problem statement which it solves. So you guys can read it here. Online financial transactions suffer constant threats from malicious agents. So, detecting fraud in real time is extremely critical to minimize financial loss and to prevent chargeback penalties and to most importantly gain customer trust because customer is investing in your bank by taking care of their trust. So, so problems like this, like arising frauds and losing money, is obviously affecting their trust. So the core business objective is to construct an intelligent decision s- support system, not a decision making system, that scans transaction streams from fraudulent signals and explains classified results to risk analysts, balancing high fraud captures and which also avoids unnecessary false alarms, which always can cause a problem to the organizations. So I would like to make one thing clear before moving into this project. This project is specifically designed for internal bank analysts or fraud analysts, not to the end users. Because obviously this is a learning project, so I have created in that way. And what different I have done in this is I haven't taken accuracy of a model to like determine the result. This is not which I have put in it. This is a dashboard which explains rather than showing accuracy that why did my system predict fraud or why did it happen like that. So the tech stack is obviously very simple, a basic core ML tech stack used by Python, a LightGBM ensemble technique algorithm, and explanation using Shapely additive performance. Which for visualization, I have used Plotly for dynamic charts, which you will see in few minutes. Matplotlib for EDA and data processing. The UI I have built using Streamlit and data processing and engineering using Pandas and NumPy. That is basic. So now let's jump into the demo. So obviously, before building the model, we need to understand the data set. That which all columns or features are impactful to take decisions that it is fraud or it is not. So this is the dataset insights. So these are the KPIs you guys can see. There are almost 20,000 transactions in the dataset, 434 features. So it is a very high dimensional dataset. And fraud rate is 0.281% with 327 missing values from it. So basically it is a very high imbalanced dataset. So to predict a result from it is difficult, but we have done it using this exploratory data analysis techniques. So we'll move to the first feature which I have taken into consideration. The first feature is say the key transaction amount and the count of transaction done over a month. So this distribution is you guys can see very highly right skewed, which means the data which is present is very strict towards the left side, extremely strict towards the left side, and the right side is pretty much empty. So what insight we have gotten from this, I have mentioned it exactly below it. Most transactions are concentrated at lower transaction amounts, and fraudulent transaction occurs across both high and low value purchases, indicating that this feature alone does not is responsible for predicting the final outcome. Now coming to the next point, product category feature. So what this gives us, what this tells us is certain product categories exhibit significantly higher fraud rates, making this feature highly valuable for gradient boosting models. So obviously for us, we have used light gradient boosting models. So this particular feature is important for making predictions. Now comes the fraud rate by card network. So there are many cards which are used in fraud transactions like debit, credit, MasterCard, Visa, American Express, Discover. So these cards are distributed like this. So you guys can see Discover has the highest value. Then comes the MasterCard and Visa, whereas American Express is very high, very less, because only certain amount of people from the world has access to the American Express card. So what insight we have got from this is different card networks demonstrate different fraud patterns, suggesting this card feature is not very impactful for making decisions. Now comes the card type. This is where it gets interesting. Credit, debit or credit. So credit and debit card exhibit different fraud behavior. Card type therefore is informative categorical feature. So you guys can see there are high fraud rate using credit card rather than debit card. Now comes the user. Which user is responsible for fraud? So how can we identify that using email domains? So I have calibrated few email addresses and count. So you guys can see Gmail has the highest value of users. Yahoo dominates the second place, and Hotmail dominates the third place. So what insight we have got from this is the majority of users belong to small number of email providers. Certain domains are more frequently associated with fraudulent activity. So we still need to investigate this. So now coming to the next feature is stop missing features. So which values are mostly missing in what columns? So there are this kind of columns. So obviously, as I said, for normal user, this column information will not make any sense because this project is only made for fraud analysts. So the dataset which is given by bank, they might know what the feature is about. So obviously, you guys can see the dataset contains 4,20,2,957 missing values across 327 features. Missingness itself carries predictive information. That doesn't mean that if I have a missing value, I should remove it or just fill it with mean or median value. So why it is missing, that should happen a scenario. So missingness itself carries predictive information and it's effectively handled by LightGBM model without requiring extensive imputation. So this is the dataset preview. This is the raw dataset preview which I have shown. So obviously you guys would not understand these columns because these are given by the bank and this is not for the end user. So you guys can see even there are a lot of missing values over here. So what are the key takeaways here? Dataset is highly imbalanced with approximately 3.5% fraudulent transactions. So that basically the dataset is having 97.5 legitimate transactions. Transaction amount alone is not insufficient to distinguish fraud. Product categories and payment card information provides strong predictive signals. Missing values are abundant but informative, making LightGBM an excellent choice. Or else we would have used k nearest neighbors or decision trees, but that wouldn't really take so many features into consideration. It would have increased my imputation or computation cost. So LightGBM, light gradient boosting was a perfect choice for me. Feature engineering and explainability are essential for building a robust fraud detection system. Obviously, you guys saw which all features were important just to know how it will predict us. Now comes to the amazing part, fraud investigation dashboard. So this is where an analyst would easily understand to check which transactions are fraud or not. So here there are few filters and select use cases. There is a probability threshold. So this threshold we will keep on increasing according to our use case. So this depends on bank to bank, whereas they should keep threshold less or low. So now just for our use case, we'll keep it 0.5 and we'll give him all cases. So basically high case, medium case, and low case, where there are chances of getting fraud. And we'll just skip on to a random transaction button. So you guys can see it has returned us a value of 3,493 transaction ID. So now this transaction ID, it has predicted as fraud, 40% of probability of fraud, which is giving us a warning because it is kind of slightly high. Whereas the actual label of the dataset is also fraud. Now, why did it predict like that? So this particular waterfall plot is coming from Explainable AI. So it uses Shapley additive predicting. So these red features indicate it is fraud, and these blue features indicate it is not fraud. So you guys can see the red feature is dominating the graph. Thus, it has predicted which feature is responsible for making it fraud. So you guys can see read it here: transaction amount, product category, card 4, card 6, address, billing address 1, billing address 2, sender's email domain and recipient's email domain. So here it is moderate risk, not high. We'll again check, we'll just increase it fraud probability to maybe 0.5. Now you guys can see that as we have increased the fraud probability, it has given us the row risk. So we guys can increase depending on the bank. And let's check one high risk transaction. Should see this is a high risk transaction. So the value is 2481. So it has given 96% fraud probability, and it is actually fraud also. The profile is red. So this will warn the internal analyst or users just to check before making further more transactions for this particular ID. So you guys can see the value is 66.3. Category is C, and the card which is used in MasterCard, and it is from debit card. Critical risk. Immediately block this transaction. Escalate profile credentials for manually security verification. So this is what the columns, the features which we saw earlier, which have converted into vector numerical value, which obviously our LightGBM model understands. So this was it for fraud investigation. Now coming to the model performance. Obviously, why did my model predict? How good it is predicting is important. So there is called as receiver operating characteristics, known as ROC curve, ROC AUC curve. So the ROC AUC score for threshold of 2.5 is 95% and 79% of average precision, and average and the accuracy 98. But I am not focusing on accuracy as I mentioned earlier, because here my main motive is to explain rather than predicting. Why did it predict fraud? Why did it go that way? Why it is severe? Why it is not severe? This graph indicates it. So the better this line is touching the left axis, the better the model is. But obviously, no model should be perfect, because AI should be generalized, not overfitting or just learning what it is given and failing on the test data. So this is the confusion heat map. So this is now what is interesting. So my model correctly classified 9,607 transactions and correctly classified fraud transaction as 241, whereas my model missed 45 transactions of fraud and incorrectly classified 107 transactions. And this is the classification report which we get using traditional machine learning techniques. Legitimate is 98% and fraud is 84%, which you guys can see over here. Now comes the explainable AI dashboard. This is where my LightGBM model is only predicting fraud based on the features which it has got. So now I will just click random fraud transactions. You guys can see this is a barometer which signifies the value which is increasing or decreasing. I'll just maybe change. So you guys can see I have changed it to the index of 4,383. My model score is 33%, 0.33%. So it is legitimate. It is predicting that my this transaction is legitimate, and actually it is also legitimate. So what explanation it has gave me? This transaction was classified as low risk primarily because feature 27 and feature 22 characteristics are influence the probability of feature 415. So now what is feature 415 and 22? Obviously for end users, this is very tough to understand. As I said, this is made for fraud analysts. So this numerical features basically mean the data which is collected by the bank. And this is the positive and negative risk reducers. You guys can see over here. Obviously, for the end users, it will be difficult, but consider it as few decisions or few columns which our bank has given through the transaction record, and that record, that particular information is signifying my model to predict fraud or not. So if you guys can get it. So local risk attribution. The blue signifies it has predicted correctly. The red signifies it has predicted as fraud. So obviously, this is a legitimate transaction. The amount of blue points are high. And this is the overall summary of all the features of my model, which has used in particularly shapely adaptive performance of explainable AI. Feature 1 dominates the dataset. Feature 22 comes the second, and likewise goes on. Now, what are the takeaways from this project? So the transparency I have shown using SHAP, which allows us to demystify complex gradient boosting predictions, explaining high risk changes in clear financial and operating terms. Obviously, you guys need to have multiple cross domain people like risk compliance people, fraud analysts people, banking audits people, and mitigating risk legal people, which can help us minimize the fraud. So, what is the fraud analyst workflow? Equipping fraud investigating this transaction which is given on past data, we can then integrate the real-time data ingestion using extract transform load, which is a further advanced technique of ML, which I will use in upcoming projects. Till then, this was the project which I have built using past data to signify which upcoming fraud will be predicted yes or no. Now comes the trust and validation part. So this is what it has demonstrated using consistent global information from various banks, triple IE, and also local transaction, which has broken down into institution confidential model rollouts. So yes, this was all about the project, and the project is also open source. You guys can check it out. I'll leave the link in the drive link or the description. So my GitHub repository also explains it pretty well. Why did it predict that way? It has screenshot from the research, the important features, and the shapely explanations. B plot. So these are the explicit features which I haven't shown in this dataset because these are specifically for ML engineers. That which dataset, which feature is important to predict what. So for the upcoming project, we can follow this pipeline, which is called ML engineering pipeline. This is mostly same for every other project, but this is the starting point for all engineering projects. You guys can check it out. So yes, that was it. Thank you guys for watching, and we'll see you in the next video.